For a non-ventilated transformer in a harsh environment characterized by dust, mist, and various process contaminants, specifying cast coils is generally the recommended approach, as opposed to utilizing dry-type coils. The rationale behind this recommendation stems from several key advantages offered by cast coil transformers. Firstly, there is a reduced risk of contamination. Cast coil transformers feature coils that are meticulously encapsulated in epoxy resin. This encapsulation creates a sealed and highly protected environment for the windings. Consequently, the risk of contamination from dust, mist, and other particulate matter is significantly reduced. These contaminants, if allowed to accumulate, could potentially lead to insulation failure or short circuits, compromising the transformer's operational integrity. Secondly, cast coil transformers exhibit higher dielectric strength. In comparison to dry-type transformers, cast coil transformers typically possess a superior dielectric strength. Dielectric strength refers to the ability of a material to withstand high-voltage stresses without experiencing electrical breakdown. The enhanced electric strength of cast coil transformers makes them more resilient to voltage spikes and surges, contributing to their overall reliability and longevity in demanding environments. Thirdly, improved moisture resistance is a notable characteristic of cast coil transformers. The epoxy resin encapsulation inherent in their design provides exceptional resistance to moisture. This is particularly crucial in environments where high humidity or condensation is prevalent. The moisture resistance of cast coil transformers prevents the ingress of water, which can degrade insulation and lead to premature failure. Fourthly, cast coil transformers offer reduced maintenance requirements. Compared to dry-type transformers, cast coil transformers typically necessitate less frequent and less intensive maintenance procedures. They do not require regular cleaning or air filtration, which can be time-consuming and costly. The reduced maintenance demands of cast coil transformers translate to lower operational expenses and minimized downtime. While an M12 enclosure can provide a degree of protection against dust and moisture, it's important to recognize that it's not a completely sealed system. Contaminants can still find their way into the enclosure through openings designed for cables or ventilation louvers. Therefore, even with an M12 enclosure in place, it remains advisable to specify cast coil transformers to further mitigate the risk of contamination. In conclusion, when considering the operating environment described, which involves a harsh setting with dust, mist, and process contaminants, opting for cast coil transformers represents a more prudent choice than dry-type transformers. Cast coils provide enhanced protection against contamination, boast high dielectric strength, offer improved moisture resistance, and require less maintenance. These combined advantages contribute to ensuring the reliable and sustained operation of the transformer under challenging environmental conditions. In further detail, considering the specific application of a 750 kV transformer with a 480 volts to 208Y/120 volts, 3-phase, 3-wire configuration, the selection of cast coil versus dry type becomes even more critical. The size and application of this transformer within a process area subject to dust, mist, and process-related airborne materials introduces additional considerations. The advantage of cast coil technology in this context extends beyond the general benefits of environmental protection, offering specific operational and safety advantages. One significant factor is the enhanced thermal performance of cast coil transformers. The epoxy resin encapsulation not only protects the coils from environmental contaminants but also improves heat dissipation. In a non-ventilated environment, this is particularly important because the transformer's ability to efficiently dissipate heat is crucial for preventing overheating and extending its operational life. Dry-type transformers, while offering a cost-effective solution in many applications, rely more heavily on air circulation for cooling. In a sealed M12 enclosure, the limited air circulation can lead to increased operating temperatures, potentially reducing the transformer's capacity and lifespan. The higher dielectric strength of cast coil transformers is especially relevant in a 480 volts to 208Y/120 volts step-down application. The ability to withstand voltage transients and surges is vital for maintaining a stable and reliable power supply to sensitive electronic equipment commonly found in process areas. These transients can originate from various sources, including switching operations, motor starts, and utility grid disturbances. The robust insulation provided by the epoxy encapsulation in cast coil transformers offers a greater margin of safety against insulation breakdown, preventing costly downtime and equipment damage. Moreover, the reduced maintenance requirements of cast coil transformers are particularly beneficial in process areas where access for maintenance can be challenging. The sealed construction minimizes the accumulation of dust and contaminants on the windings, reducing the need for frequent cleaning and inspection. This is in contrast to dry-type transformers, which may require more regular maintenance to ensure proper ventilation and prevent the buildup of contaminants that can impede cooling and degrade insulation. In terms of safety, cast coil transformers offer inherent advantages due to their fire-resistant properties. The epoxy resin used in their construction is self-extinguishing and does not support combustion. This reduces the risk of fire hazards, particularly in environments where flammable materials may be present. Dry-type transformers, while generally safe, do not offer the same level of fire resistance. The choice of an M12 enclosure is a good first step in protecting the transformer from environmental contaminants. However, it's essential to recognize the limitations of even a well-sealed enclosure. Over time, seals can degrade, and openings for cable entry and conduit connections can allow contaminants to enter. The additional protection afforded by cast coil technology provides a critical second layer of defense against these contaminants, ensuring the long-term reliability and performance of the transformer. When specifying a transformer for a harsh environment, it's also essential to consider the specific types of contaminants present. For example, if the process area involves corrosive chemicals or solvents, the epoxy resin used in cast coil transformers can be formulated to provide resistance to these substances. This level of customization is not typically available with dry-type transformers. In addition to the technical advantages, the life cycle cost of cast coil transformers can be lower than that of dry-type transformers in harsh environments. While the initial investment may be higher, the reduced maintenance requirements, extended lifespan, and improved reliability can result in significant cost savings over the transformer's operational life. Furthermore, the environmental benefits of cast coil transformers should not be overlooked. Their energy-efficient design and reduced risk of failure contribute to minimizing energy consumption and waste. In conclusion, for 750 kVA, 480 volts to 208 Y/120 volts, 3-phase 3Y transformer operating in a harsh process environment with dust, mist, and process-related contaminants, specifying a cast coil transformer is the superior choice. The enhanced thermal performance, higher dielectric strength, reduced maintenance requirements, improved safety, and customized protection against specific contaminants offer significant advantages over dry-type transformers. While the initial cost may be higher, the long-term benefits in terms of reliability, lifespan, and reduced operational costs make cast coil transformers the more cost-effective and environmentally responsible solution. To further elaborate on the key differences between cast coil and dry-type transformers in the context of harsh environments, let's delve deeper into the specific design and material properties that contribute to their respective performance characteristics. Cast coil transformers, as previously mentioned, utilize epoxy resin to encapsulate the windings. This epoxy resin is not just any off-the-shelf material, it's a carefully formulated compound designed to meet the demanding requirements of transformer applications. The epoxy resin provides several critical functions, including electrical insulation, mechanical support, and environmental protection. The specific formulation of the epoxy resin can be tailored to provide resistance to various environmental factors such as moisture, chemicals, and extreme temperatures. This customization allows cast coil transformers to be used in a wide range of challenging environments. One of the key advantages of epoxy resin encapsulation is its ability to create a void-free insulation system. Voids or air pockets within the insulation can lead to electrical stress concentrations and premature failure. The vacuum casting process used to manufacture cast coil transformers ensures that the epoxy resin completely fills all spaces around the windings, eliminating voids and maximizing dielectric strength. In contrast, dry-type transformers rely on air and varnish or other coatings for insulation. While these materials can provide adequate insulation in many applications, they are more susceptible to degradation from moisture, dust, and other contaminants. The air gaps within the insulation system can also create pathways for contaminants to accumulate, leading to reduced insulation resistance and increased risk of failure. The thermal performance of cast coil transformers is also significantly influenced by the epoxy resin encapsulation. The epoxy resin acts as a thermal conductor, helping to dissipate heat from the windings to the surrounding environment. This is particularly important in non-ventilated environments where air circulation is limited. The ability of the epoxy resin to efficiently transfer heat allows cast coil transformers to operate at higher loads without overheating. In dry-type transformers, the cooling process relies primarily on air convection and radiation. The windings are exposed to the air, allowing heat to be dissipated through natural air circulation. However, in harsh environments where dust and contaminants can accumulate on the windings, this cooling process can be significantly impaired. The buildup of contaminants reduces the surface area available for heat transfer and can lead to increased operating temperatures. The mechanical strength of cast coil transformers is another important consideration. The epoxy resin encapsulation provides excellent mechanical support to the windings, protecting them from vibration, shock, and other mechanical stresses. This is particularly important in process areas where equipment may be subject to vibration or impact. Dry-type transformers, with their exposed windings, are more susceptible to mechanical damage. The windings can vibrate and rub against each other, leading to insulation wear and eventual failure. The choice of conductor material also plays a role in the performance of transformers in harsh environments. Copper is the most commonly used conductor material due to its excellent electrical conductivity and corrosion resistance. However, in environments where corrosive chemicals are present, aluminum conductors may be a better option. Aluminum forms a protective oxide layer that resists corrosion from many chemicals. The design of the transformer core is also an important factor to consider. The core is the magnetic circuit that provides a path for the magnetic flux to flow. The core material is typically made of silicon steel laminations which are stacked together to form the core. The core design can influence the transformer's efficiency, noise level, and ability to withstand short-circuit forces. In harsh environments, it's important to choose a core design that is robust and resistant to corrosion. In addition to the transformer's design and materials, the installation practices can also affect its performance in harsh environments. It's important to follow the manufacturer's recommendations for installation and maintenance. This includes ensuring that the transformer is properly supported, that the connections are tight, and that the enclosure is properly sealed. Regular inspections and maintenance can help to identify and correct any problems before they lead to a failure. This might include periodic cleaning of the enclosure, inspection of the windings for signs of damage, and testing of the insulation resistance. By carefully considering the design, materials, installation, and maintenance of transformers, it's possible to ensure reliable and long-lasting performance in even the most challenging environments. Ultimately, the decision to specify cast coil or dry-type transformers depends on a variety of factors, including the specific environmental conditions, the load requirements, the budget constraints, and the desired level of reliability. However, in harsh environments where dust, mist, and process contaminants are present, cast coil transformers generally offer superior performance and protection compared to dry-type transformers. To further underscore the advantages of cast coil transformers in demanding environments, let's examine specific scenarios where their unique characteristics provide significant benefits. Firstly, consider applications in wastewater treatment plants. These facilities are inherently exposed to high levels of moisture, corrosive gases, and biological contaminants. The encapsulated windings of cast coil transformers are impervious to these harsh elements, preventing insulation degradation and ensuring reliable operation. Dry-type transformers, on the other hand, are susceptible to moisture ingress and corrosion, which can lead to premature failure and costly downtime. Secondly, explore the use of transformers in mining operations. Mining environments are characterized by heavy dust, vibration, and extreme temperature variations. Cast coil transformers are designed to withstand these punishing conditions, providing robust and dependable power distribution. The mechanical strength of the epoxy resin encapsulation protects the windings from vibration and shock, while the thermal conductivity of the resin helps to dissipate heat in confined spaces. Dry-type transformers, with their exposed windings, are vulnerable to dust accumulation and mechanical damage, which can compromise their performance and safety. Thirdly, consider applications in the chemical processing industry. Chemical plants often involve corrosive chemicals and flammable materials. Cast coil transformers can be specifically formulated to resist chemical attack and provide a high level of fire resistance. The epoxy resin used in their construction is self-extinguishing and does not support combustion, reducing the risk of fire hazards. Dry-type transformers, while generally safe, do not offer the same level of chemical resistance and fire protection. Fourthly, examine the use of transformers in offshore oil and gas platforms. These platforms are exposed to saltwater, humidity, and extreme weather conditions. Cast coil transformers are designed to withstand these harsh marine environments, providing reliable power for critical equipment. The epoxy resin encapsulation is resistant to saltwater corrosion and provides excellent insulation in humid conditions. Dry-type transformers are susceptible to saltwater corrosion and moisture ingress, which can lead to rapid deterioration and failure. Fifthly, consider applications in food processing plants. Food processing facilities require high levels of hygiene and sanitation. Cast coil transformers can be easily cleaned and sanitized, preventing the growth of bacteria and other contaminants. The smooth, non-porous surface of the epoxy resin encapsulation does not harbor dirt or moisture, making it ideal for these environments. Dry-type transformers, with their exposed windings, are difficult to clean and sanitize, posing a potential risk of contamination. In each of these scenarios, the unique characteristics of cast coil transformers provide a clear advantage over dry-type transformers. Their robust construction, environmental protection, and reliable performance make them the preferred choice for demanding applications where downtime and safety are critical concerns. In summary, when specifying transformers for harsh environments, it's essential to carefully consider the specific operating conditions and the potential risks associated with each type of transformer. Cast coil transformers offer a superior level of protection and reliability, making them the ideal choice for applications where performance and safety are paramount. To provide a more comprehensive understanding of the selection process, let's explore the relevant industry standards and guidelines that govern the design, testing, and application of transformers in harsh environments. Firstly, the International Electrotechnical Commission (IC) is a global organization that develops and publishes international standards for electrical, electronic, and related technologies. IEC Standard 60076-11 specifically addresses dry-type transformers. This standard specifies the requirements for dry-type transformers, including their design, testing, and performance characteristics. It also provides guidance on the selection and application of dry-type transformers in various environments. Secondly, the Institute of Electrical and Electronics Engineers (IEE) is a professional organization that develops and publishes standards for the electrical and electronics industry in North America. IEE Standard C57.12.1 covers dry-type transformers. This standard is similar to IEC Standard 60076-11 but includes some additional requirements specific to the North American market. Thirdly, the National Electrical Manufacturers Association (NEMA) is a trade association that represents electrical equipment manufacturers in North America. NEMA publishes standards for electrical enclosures, including NEMA 12 enclosures. NEMA Standard 250 specifies the requirements for NEMA enclosures, including their degree of protection against dust, moisture, and other environmental factors. Fourthly, Underwriters Laboratories (UL) is an independent testing and certification organization that tests and certifies electrical products for safety. UL listing is often required for transformers used in commercial and industrial applications. UL Standard 1561 covers dry-type transformers. This standard specifies the safety requirements for dry-type transformers, including their insulation, grounding, and overcurrent protection. These industry standards and guidelines provide valuable information for selecting and applying transformers in harsh environments. They specify the requirements for transformer design, testing, and performance, ensuring that transformers meet the necessary safety and reliability standards. In addition to these standards, it's also important to consult with transformer manufacturers and industry experts to obtain specific recommendations for your application. Transformer manufacturers can provide detailed information on the performance characteristics of their products and can help you select the best transformer for your specific needs. Industry experts can provide valuable insights into the challenges of operating transformers in harsh environments and can help you develop a comprehensive maintenance plan. By following these guidelines and consulting with experts, you can ensure that your transformers operate safely and reliably in even the most challenging environments. In conclusion, when specifying transformers for harsh environments, it's essential to consider the specific operating conditions, the relevant industry standards, and the recommendations of transformer manufacturers and industry experts. Cast coil transformers offer a superior level of protection and reliability, making them the ideal choice for applications where performance and safety are paramount. By carefully considering all of these factors, you can ensure that your transformers operate safely and reliably for many years to come.